Coach Fred here, and so this is kind of a follow-up to polynomial long division. So if you thought polynomial long division was kind of confusing, lots of room for error, well, I'm going to let you in on a little secret. There is a shortcut, but this shortcut can only be used if the divisor is a linear factor. So what do I mean by that? So look at this factor, the number that we're going to divide it by, the divisor. It's linear because the highest exponent is 1. So you can use polynomial long division if the divisor is quadratic, cubic, and so on. So this shortcut that you're really going to like can only be used if that divisor is linear. Okay, so I'm going to show it to you, but I'm going to do it using long division first, okay? So remember, we take our divisor and we divide it into our dividend. So x cubed minus 14x plus 51x minus 54. We make sure that, 51x, 14x squared. We want to make sure every degree is listed from 3 all the way down, which it is, so I don't have to put in any placeholders. Okay, so now we divide. So x goes into x cubed, x squared times. I'm going to line it up over the 14. I'm going to multiply x squared to x plus 2, giving me x cubed plus 2x squared. Then I'm going to subtract. So that's going to make this minus and this minus. So negative 16x squared. I'm going to bring down the 51. I'm going to multiply or divide x into negative x squared, 16x squared, which is going to give me negative 16x. Going to line it up over the x. I'm then going to multiply negative 16x to x plus 2, giving me negative 16x squared plus 32x. I'm sorry, minus 32x. Let me fix that. But then I'm going to subtract. Right? So that's going to make this positive and this positive. Let's just remember that. That's what's happening. Okay. Give me a really big number here. What is that? 83x. Bring down the negative 54. See, look at all this room for error. All right. And so I'm going to divide 83x by x. That's going to give me 83. I'm going to multiply again. So 83x plus, what is that, 166? Yeah, 166. I'm going to subtract, so that's going to make this minus and this minus, which is going to cancel, and then that's going to give me negative 220. Okay, and so I'm going to write that over the original divisor. Okay, so that was how we would do it if we were doing polynomial long division. Now, I would know I went through that long, but I wanted to compare this. Synthetic division, it's derived from the ordinary long division algorithm, okay? It uses the coefficients to all of our divisors and the 0 of the linear factor. All right, so what do I mean? First, I find the 0 by setting it equal to 0. So I'm going to be dividing by x equals, I'm going to be dividing by negative 2. So I'm going to put negative 2 in this little box right here. And then next to it, I'm going to list all the coefficients of my polynomial. If there are any missing from 3 down, you have to put in a placeholder 0. All right, so I write down my coefficients. So 1, negative 14, 51, negative 54. Okay, now in class, my class, we are going to investigate why this works. Remember, this video is really just how we do it, okay? All right, so I'm going to bring down the 1 and make a line all the way across, okay? Now I'm going to multiply negative 2 times that 1 right there, okay? Negative 2 times 1, I'm going to place it right up here, which would give me negative 2, and then I'm going to add the numbers down. So that's going to give me negative 14 minus 2, so negative 16. I'm going to multiply the negative 2 times the negative 16, giving me positive 32, which I'm going to add them down, and so that's going to give me 83. Okay, these numbers should be starting to make sense to you now. And then I'm going to multiply negative 2 times 83, which is going to give me negative 166, I'm going to add down, and so that's going to give me negative 220. Now, I like to put a little line here for myself because I'm hoping that you notice that what you ended up with is that part of your answer. We call this the depressed polynomial, or we can use these coefficients to write a depressed polynomial. Depressed polynomial is the degree of this polynomial down 1, right, or minus 1. So this would be my x squared term, this would be my x term, this would be my constant term, and again, this is going to be your remainder. And then I'd be writing it over my original divisor. So you can see it really is a shortcut. Again, I want you to recognize we call this the depressed polynomial. It comes from the coefficients that you get using synthetic division. As long as you recognize you have to go from your original polynomial down 1 degree. Now, if the remainder were 0, then this would then be a factor of the polynomial. And if it's really of higher degree, you might be able to even factor that depressed polynomial. And we're going to talk about that a little bit more, okay? All right, so hopefully that was helpful. We're going to try in one more time. So my suggestion here is I'm going to do this, but I would press pause, try it by yourself, okay, and then come back and check your work, okay? So I'll give you a second to pause. All right, so I'm going to put my -5 because it's saying that -5 is the factor, okay? Or is the 0, maybe we should say, is the 0. All right, so we're going to put in 1, 7, -38, and -240, okay? Now we're trying to see if this is a factor or is a 0, okay? All right, so now I'm going to bring down my 1. I'm going to multiply -5 times 1, give me -5. Going to add down, giving me 2. -5 times 2 gives me -10. I'm going to add down, that gives me -48. -5 times -48 gives me +240. Right? And that gives me a remainder 0. Now remember, this is going to lead me to my depressed polynomial. I was originally a degree 3, so my depressed polynomial is going to be a degree 2, x squared plus 2x minus 48. Because the remainder was 0, it tells me that -5 is a 0 because it goes in evenly. So then x plus 5 is a factor, is a factor of the polynomial. Now, what's really interesting is this depressed polynomial can be factored. So I'm going to do that. I'm going to factor that into x plus 6, x plus 8, x minus 6. That's going to give me x squared plus 2x minus 48. So if I wanted to say, I wanted to write this in factored form and find all my zeros, right? I'll write them down here. I have x plus 5 is a factor. I have x plus 8 is a factor. And I have x minus 6 is a factor. All right, so what can we do with that? Well, now we can sketch it putting all of this together, okay? So I'm going to make this a function. I see that the degree we see in both ways. Here it's 3, and here if we add the exponents, it's 3. The leading coefficient is positive. That tells me my end behavior is down, up. My y-intercept, so let me find my y-intercept. I'm going to let x be 0, so that's going to give me 5 times 8 times -6. So 40 times -6, so 0, -240 is my y-intercept. And I have my x-intercepts. -5, 0, -8, 0, 6, 0. And I can see they all have a multiplicity of 1, so therefore my graph's going to go right through it, those x-intercepts. Okay, now I'm just doing a quick sketch, so I'm not going to find any other additional points, but you certainly could find points between all of these. So we have -8, -5, -6. We know it's down, up. We know we have this y-intercept way down here, negative 240. So I'm going to go up. I'm going to turn around somewhere. I'm going to go down. I'm going to cross my y-axis. I'm going to go up through 6, something like that. Okay, now just as a reminder, I could find points here and between here and here, like actually anywhere between here and here, by just creating a table and plugging some inputs in to get your outputs. All right, so that's why we need polynomial long division and synthetic division when something isn't factorable, because it can help us quickly or in some way get our x-intercepts of a function. Okay? All right, guys, hopefully that was a helpful video. Have a great day.